All right, so we're still collecting data, and we're going to talk about simple random samples today. We have talked about sampling methods that are good and bad in lesson 3.2, which was, you're welcome, very short and easy. This one also is not too bad, but there's some calculator work and whatnot that we'll be doing on this. So, I should probably turn my board back on. So to turn it off because I got in my email. Okay. So we're going to do these things today. We're going to talk about how to obtain a simple random sample using slips of paper or technology. The technology that we're going to use is going to be the TI-84 calculator. We'll talk about sampling variability and what happens if we increase sample size, and we're going to use a simulation. And we're going to do a bit practice on this on Thursday. We're going to do like an activity to solidify all of this. All right, so simple random samples. The idea is that in a simple random sample, right, you're going to grab a small group of people from the entire population that represents that population. And in order for that group that you took out to be a simple random sample, each person or each thing that you selected has to have the same chance of being chosen. So that is what it is. And from now on, I'll usually say SRS instead of simple random sample. For sure, if I'm going to write it, I'm writing SRS, not simple random sample. So keep that in mind. Remember that N, the variable N, is always going to represent our sample size. And then that little paragraph just says what I just said in real person talk. Okay, so we're talking about doing this with technology, sitting there writing all those numbers on a piece of paper. We just use a calculator instead. So in our calculator, what we would do is the same thing that we would do in the first case, right? We're going to give everybody a number, right? We're going to go, 1 through, if there were 50 people, we would give them numbers 1 through 50, right? And then we're going to use a random number generator, in this case, our calculator, to obtain a certain number of numbers. Excuse me. I don't know why I'm feeling tired. Okay. Let's talk about how to do that with our calculators. So here is our handy dandy TI-84 calculator. And don't worry, I'm going to also write these commands down for you all so that you have them. You can follow these steps as we go. This is how I would generate a random set of numbers. So let's say we're doing it for, let's say I was trying to do it for this particular class. I've given you all numbers 1 through 13. And then I'm going to go to math. And I'm going to scroll over to probability. Choose randint. And it's going to ask me, from what number to what number do you want me? So I want to select randomly a number from 1 to 13, since there are 13 of you. So I'll put in 13 there. And what was I saying? I was saying I was randomly selecting 4 of you. Okay. So I hit enter. It spits this out. And there we go. I selected student number 13, 2, 1, and 8. Now we've got to be careful. This number generator does not know to not repeat numbers, right? And it would be weird if I selected you twice for a sample of 4. Well, then there would only be 3 people, right? Because, you can't be 2 people at the same time. And that is a fact. I know. You might think of ways that you could maybe be 2 people at the same time. And I'm going to refute that. Only if there was a glitch in the matrix, right? The simulation's broken. Then there can be 2 of you. Just kidding. It's real. It's not a simulation. Okay, so we selected 4 people. Let's talk about the steps that we would take in order to do that. So let me write down these calculator commands for you so that you have it for your reference. Okay, so you're going to hit from your main calculator screen. You're going to hit math. Then you're going to scroll over to prob for probability. And you're going to go down and you're going to choose rand int. Do not choose rand. If you choose rand, you're going to get a bunch of weird decimals, right? And we're assigning people numbers that are whole numbers. So if we get spit out decimals, it just gets weird. You know, much better to just have it spit out integers. All right, in that, it's going to ask you for a lower and an upper. So your lower is always going to be 1, unless you decide to start at 2, which would be strange. And then your upper that it's asking for is going to be the number of people you're selecting from. A number of things you're selecting from, or it could be people, could be other stuff. I hate that. Okay, from. Okay. And then n is the number selecting. The number in your sample, let's say that. AKA the sample size. Okay. And it spits out a command that looks like this. Rand int, and this is going to be I'm going to try right there. Lower, upper, n. That's how it spits it out. Give you guys a minute to write that down. Man, I accidentally dried a chapstick, and I thought that I had made it scot-free. I didn't ruin any clothes. It turns out that I was wrong. Melted chapstick on the pants. It's the worst. All right, so we have done this. Awesome. Don't believe there's anything more on this slide. Like I was saying, we need to make sure that we're doing it without replacement, right? We can't choose the same number twice, is what that means, because then we would have chosen one person to be 2 people, and like I said, that only works if the simulations work. Okay, so yeah, that's it. I guess Mr. McCourtney did some activity with Federalist Papers, and they looked at what the average word length is in the Federalist Papers. The idea is that when we take a sample from a population, of course, we're not going to get exact numbers, right? There's going to be some variability. It's going to vary from the actual number in the population. So, for instance, if I was going to want to find the average height, if I was interested, what is the average height of a student here at Cleveland High School, right? I could find out the heights of every single student, and I could find out the average height, the actual true average height of the population of students. And then if I was to take a small sample of those students, right, and then find the mean of the sample, right, it's never going to be exactly the same. There's going to be some variability in the means of each of my samples, right? There might be, I might grab a group of students that maybe has one really tall kid in it, right? So that average of that sample is going to be really high. I might accidentally grab a number of different small students, right? And so that sample mean is going to be very small. So there's going to be some variability. But if I take a lot of samples, we'll wind up kind of having those means clump around the true population mean. And that's sampling variability. So if we look at these two right here, right, this random sample has a lower amount of variability than this student sample, right? Because we can see the student sample is more spread out. And that's essentially what we're looking for. And like I was saying, the way to eliminate or to decrease sampling variability is by using a larger sample, which you can see here, right? So in this case, they used samples of size 5 and found an average for each of those samples, right? But if we take a bunch of samples of size 20, our average is going to get closer to the true average, and it's also going to decrease the amount of variation. This is just what I was trying to, what I was telling you, right? We're going to, a lot of times we're dealing with populations that are so huge, there's no way that we could sample, that we could get information or data from everyone in that sample. So what we have to do is just collect a representative sample. So if I wanted to find, and what I mean by representative sample is, if I wanted to know what the average height is of students at Cleveland High School, right, I wouldn't just pick seniors. I would make sure that I had an even amount of freshmen, seniors, and sophomores, maybe some juniors in there too, who knows. Yes, I would put juniors. Because that way I wouldn't wind up with people that were too tall, right? If I just selected seniors, I would probably get an overestimate because, you guys have had some time to grow. All right. We'll get into making inferences about population later. All right, so let's go ahead and do an example. What proportion of students at your school use Twitter? Okay. Sorry, I thought about something else when I thought about Twitter, and my brain gets distracted quite easily. So we're going to take a sample of students from the school and describe how we would. So how would I select a simple random sample of 50 students? And so I would, whoa. I would assign each student a number. Good grief. A number. A number from 1 to 50. Then use rand int. Oh, wait, my bad. How many students are there? Every student in the school, sorry. My bad, my bad. From 1 to, right, our max number. I guess it would be sufficient to say just assign each student a number. Then use rand int to generate 50 numbers. I don't know why I keep trying to start with an M when I spell a number. 50, I swear that's a 50, not a so. 50 numbers. The students assigned to those 50 numbers are selected. Uh, 50 numbers are selected. Should have had more room. All right, will it be exactly the same as the true population proportion? Explain. No, because samples will vary. Sample proportions? Sure. Or you could say no because of, sampling variability, all of those things. So which is going to be more likely to yield a sample result closer to the true population value? 50 students, of course, 100. Because increasing the sample size decreases sampling, it decreases variability. Awesome.